Today we're going to look at the last section of Chapter 8, dealing with logarithmic and exponential equations. In this section we're going to learn how to solve logarithmic and exponential equations. And a logarithmic equation is an equation containing the logarithm of a value. For example, 2 log x equals log 36. Okay, a couple of equality statements for exponentials and logs. We've seen these before, but if your bases are the same, remember back in exponentials, if I could get one base the same, the exponents are equal. Similar with logarithms, if I can get a single logarithm of the same base on both sides, then the numbers inside the logarithm would have to equal. Alright, so let's take a look at our first example. We are asked to solve this logarithmic equation, so we're going to be using our logarithm laws to help us do this. So I want to get one single logarithm on this side. So to do that, I can combine these two because I'm adding, if I multiply the 4 and the x together. So therefore log base 7 of 4x equals log base 7 of 12. And now I have a single logarithm of 7 on each side, which means the inside parts of the logs have to equal. So 4x equals 12. Therefore, x equals 3. Okay, in our next example, notice not every term has a logarithm. So what I want to do in this case is I want to get all the logarithms on one side. So I'm going to add the log base 2 to the left-hand side and just have the 3 by itself. Now I can combine those two using my product law for logarithms. Now, because I only have a single logarithm on one side, I have to convert to exponential form. So 2 raised to the power of 3 is going to equal whatever's inside the logarithm. So it's going to equal x minus 6 times x minus 4. 2 to the third is 8. If I FOIL out the right-hand side. So now I'm trying to solve a quadratic equation, so you should make it equal 0. So I have x squared minus 10x, and 24 minus 8 is going to be positive 16. And therefore, this will factor into x minus 2 and x minus 8. And therefore, x is 2 or x is equal to 8. Now, when you get your two solutions, you have to make sure that when you substitute them back in, they don't make those parts inside the logarithm negative. And you notice 2 will make those negative, so 2 is invalid. The only valid solution is 8. Okay, in our third example, what we can do, first of all, is I can bring the 5 out front using our power law. Now I can divide both sides by 5. This 5 takes out that 5, so I'm left with log base 3 of x squared minus 8x is equal to 2. And now I convert to exponential form, so 3 raised to the power of 2 is going to equal the function inside my logarithm, which is x squared minus 8x. 3 squared is 9, so I'm going to subtract the 9 over to the other side. And now this factors into x minus 9, x plus 1. So either x is 9 or x is equal to negative 1. And we evaluate back in the original to make sure that these values do not make this negative. If I put a 9 in there, 9 squared is 81. 81 minus 72, that's positive, that's a valid solution. And don't be fooled on this one, just because x is negative. If I put a negative 1 into there and square it, it's 1. Minus 8 times negative 1 is plus 8. This 2 will also work, so both answers are valid. Okay, so that was solving logarithmic equations, and now we're going to look at solving exponential equations using logarithms. Now in chapter 7, we introduced things like this. If we had 2 to the x equals, let's say, 8. Well, I could get 8 in base 2, and since the bases are the same, x would equal 3. But what would happen if I had this? 2 raised to the x equals 7. Now 7 you can't get in base 2. So the only way we can solve an exponential equation is to use logarithms. So the first thing I do when we're solving an exponential equation, first of all, we cannot get 2500 in base 2. So what I do is I take the common logarithm, which is log base 10, of both sides. Now why am I using log base 10? Because then now I can use my calculator, because my calculator is in log base 10. So now I can move that x out front. And now I'm going to divide both sides by log 2, and log 2 is just a number on my calculator. So now you're going to type in log 2500 divided by log of 2, and that should equal 11.288 if we go to, well, it says 2 decimal places in the question, so let's go 11.29. Now, if you wanted to check your answer, you could put 11.29 back into the original equation, and that should be close to 2500 because we rounded off. So 2 raised to the 11.29 is 2503. So it's a little bit big because we've rounded off, but that is how you can verify whether or not your answer is correct. Okay, this question, a little bit different because we have a binomial as my exponent. First step is you can't get both sides in base 5, so you're going to take the logarithm of both sides. So log of 5 raised to the x minus 3 is log of 1700. Now the x minus 3 can come out front, and make sure you put that in brackets because it is being multiplied all by log 5. Now I can divide both sides by log 5. So I'm left with x minus 3 equals log of 1700 divided by the log of 5. And now I could just add 3 to the right-hand side to get x by itself. So if I work this all out, I'm going to get log of 1700 divided by the log of 5, and that equals 4.621 plus 3. So my answer for x is 7.62 if you go to 2 decimal places. All right, the next example, we have an exponent on both sides of my equation. So same thing, I take the logarithm of both sides. Now we bring our exponents out front. Okay, so now at this point, these guys are just decimal numbers on your calculator, so I'm going to distribute them. So I distribute the log 6, and I'm going to get 3x times log 6, and log 6 times 1 is going to be log 6. Now I'm going to distribute the log 8 and get x log 8 plus 3 log 8. Now I'm going to gather all the terms with x's on one side and move the terms without x's to the other side. So I'm going to subtract the x log 8 to the left-hand side, and I'm going to subtract the log 6 to the other side. Now, my goal is to solve for x, so I have a common factor of x here. So I'm going to factor out an x And now I have to divide both sides by 3 log 6 minus log 8 and 3 log 6 minus log 8. So these are going to cancel. And now you have x isolated. And so now you just have to be careful how you punch this into your calculator. So it's going to be 3 log 8 minus log 6, all divided by 3 log 6 minus log 8, and I get an answer of 1.35 when you round off to 2 decimal places. So that's probably as hard as they get. So if you understand this example, you should be good. Okay, your assignment from your textbook is right there, page 412. And I cut and pasted the handout that you would have gotten in class. So there's 1 to 18 and 19 to 32. And the answers are all there. And it says just do the odd numbers. Again, if you find that's too much, maybe just do a third of them. It doesn't matter to me, but these are just some extra practice questions because our textbook doesn't have many of this type. Okay, so that ends the first part of section 8.4. So if you have any questions, feel free to email me. If not, have a good day.